Hey folks, let's go through this set of lecture notes on arteries and veins and structures called anastomoses. Just hide this. See if I can make this a little bit bigger. The reason I'm showing it this way is because these drawing tools go away if I put it in present mode. So anyway, let's just go through this. Artery physiology, of course, physiology is what the arteries do. What are they for? Get out of here. Arteries generally distribute oxygenated blood, but there is an exception, and of course, the exception is going to be pulmonary arteries. The pulmonary arteries are ones that conduct blood away from the right ventricle of the heart and are bringing blood to the lungs to get oxygenated blood. So that's the exception. The interesting thing about arteries is that they can expand, they can stretch, and they contract with every heart stroke, every heartbeat. So when the ventricles squeeze, that's of course a ventricle systole, that actually causes the arteries to actually stretch a little bit. So if as the heart squeezes, the arteries stretch. And that's why you can actually, sort of feel your pulse. What you're feeling is the heart rushing, the heart squeezing, and then the blood rushing through your arteries as a result of that ventricular systole, and then your arteries kind of stretch. And so that's the pulse that you actually feel. The other thing that's kind of interesting is that arteries can contract, and they contract because they have musculature, which is known as tunica media. Let's move on to the next slide here. I gotta switch my tool. This is actually histology, right? So this is showing you microscopic cross section. And so what we have right here, let me go back to my, actually I'll use this tool. What you have here, this is the artery as it's labeled. And what you'll notice is the wall of the artery is kind of thick. So this open space in the middle here, that's where the blood would be flowing through. This over here is a vein. Now notice that the artery kind of retains its shape, has this thick muscular wall, but the vein kind of gets squashed. This slide was sliced, this tissue section, it was sliced. So sometimes the act of slicing deforms the way that the tissues actually line up. But notice the vein is a thin wall structure. It's kind of irregular. It's not this like oval form that you're seeing here in the artery. The vein has a tougher time holding its shape. All right, so let's move on here. Let me get out of this. Come on. All right, so this is a cartoonish representation of how veins look on the right side of the screen and then how arteries look on the left side of the screen. So you'll notice that the thickness of the wall of the artery is considerable relative to the thickness of the vein. Okay. And then the opening or the lumen, this word lumen means opening. It's the open space. Like you have a lumen of your stomach, that's the interior open space. You have a lumen of your intestines. So the inside open space, we use the word lumen to describe that. The lumen of veins is generally wider in diameter than the lumen of arteries. We've got these layers here. Notice in the bold, tunica intima, tunica media, and tunica externa. So this is the internal layer of cells, which is in intimate contact with the blood. All right. The other thing to know, the media or the middle layer or the middle tunic is where there's musculature. Now, this musculature is smooth muscle. It's not skeletal muscle and it's not cardiac muscle because this isn't attached to bones. That's why it's not skeletal, and it's not cardiac muscle because it's not part of the heart itself. There is musculature in veins, but the thickness and the robustness, the strength of the muscle is much more profound in arteries than it would be in veins, which is why veins are more prone to that collapsing um, sort of structural process, right? So that's why it looked this way in that slide that I showed you before. Okay, so this is another look at it. And what you'll notice is that in general, when our arteries and veins are closer to the heart, they generally tend to be larger. Okay. And so as you go in farther vascular distance away from the heart, the diameter of the blood vessels, of course, are going to diminish until you finally get down to these little capillaries. And we've discussed this before, right? Capillaries, in some cases, the diameter of a capillary might be less than the diameter of a red blood cell that's trying to pass through it, which is why, it's so critical that red blood cells can fold over and then sort of roll up like a tortilla, um, so that they can find their way through those tiny blood vessels. All right. Um, and again, what I would ask you to notice is that arteries are muscular. Okay. All right. Looking at this actually shows the relative thickness of externa, media, and intima for these three types of arteries, right? So you've got elastic arteries, muscular arteries, and then arterioles. So if we go back to this, this is referencing elastic arteries, muscular arteries, and arterioles. So these do diminish in size and thickness as these arteries branch off and then become smaller and smaller. And so we see more cell muscle layer in the large elastic arteries. We still have a considerable number of cells, muscle cells, in the muscular arteries, but not so many in arterioles. But these cells that are shown right here, oops, didn't mean to change the format of that. These cells, those are muscle cells. So even arterioles can squeeze. All right. And of course, the function of that, there's a reason for it. All right. Let me go back to, all right. Um, okay. Now, veins, let's move on to veins here as we think through this. Generally, veins are conducting deoxygenated blood back to the heart, and the exception, of course, is going to be the pulmonary. Because the pulmonary veins are conducting blood back from the lungs and bringing them into the heart. And of course, that blood has just been freshly oxygenated. Veins have the same three tissue layers, so intima, media, and externa. Um, the intima layer and the media layers are generally thin, not very strong, but the external layers in veins are pretty thick. Veins generally aren't as strong as arteries. Um, and of course, the other key distinction between arteries and veins is that the veins have the internal one way valves, which is really critical for getting blood to return back to the heart because there's no pressure in the veins from the heart squeezing. The, the force that pushes blood back to your heart is actually your body movement and your skeletal muscles squeezing the blood in your veins, and those valves force the blood to direct back to your heart and not pool in the extremities of your bodies. All right, moving on here. Oops, I'll go back to this. Anastomosis. So these are what are called collateral, right? Collateral circulation pathways, and they're inherently redundant. So there's an anastomosis, like where blood crosses over from your thumb side to your pinky side in your hand. Um, and what that means is that blood from the radial artery, and of course the radius follows the thumb, right? Blood from the radial artery can end up over here in the pinky, all right? And blood that's coming from the ulnar artery can end up over here in your thumb if necessary. So this structure right here is inherently a collateral redundancy. So why is that important? Well, if you had for some reason some blockage of blood flow in your radial artery, well, that could present problems for blood flow ischemia, right? Lack of blood flow distally from where the site of the blockage would be. Let's say we had some type of blockage there. Well, the thing is this redundancy here allows for blood flow from the ulnar artery to cross over and then still supply blood for your extremities on this radial side of the hand. So these anastomoses are really critical, and can prevent ischemia or lessen the effect of ischemia, which is blockage of blood flow, um, to distal structures because they're redundant. Um, let's move on. I'll show you another. Oops, I didn't need to do that. Let's get out of this. Um, so on this shows you. Let's see if I can get rid of this for a second. This shows you um, anastomotic structures crossing across the brain from the left to right side. So these communicating arteries, let me go back to my marking tools here. The communicating arteries, right? These communicating arteries here cross blood from the right to the left side of the brain. Um, and there's a posterior communicating artery too. So this structure of the anterior and the posterior communicating arteries is known as the circle of Willis, which is an eponymous term for a doctor named Thomas Willis, who was an English physician and apparently was really important, so named the structure after himself. Anyway, what this means is that if blood is coming up from your right side carotid artery, let's see, this would be the right side. Um, and there was some blockage in the left side carotid, what could happen is that the opposite side of the brain can still be supplied with blood, even if there's a compromise for blood flow in your carotid arteries that join up in here. Okay, so that's another critical anastomosis structure. I like this model here because it just kind of shows how much of your blood is where in your cardiovascular system at any given point of time. Now this is average, so situations can vary, of course. Let's see if I can bring myself back. Hey, I'm back. All right. Anyway, um, at any given moment, according to the way you read this chart, at any given moment, about 7% of your blood volume is in your heart, right? Most of your blood volume is actually in your veins at any one given time. Now, this can change depending on activity level, right? So, if you're really pushing your body hard and you're doing some type of vigorous exercise, these veins will, there's going to be more circulation in general. And, one of the things that gets dangerous is when people don't move around a lot, is especially like on long airplane flights or something like that, you can suffer from a condition called deep vein thrombosis, where some of the deep veins in your legs, blood can pool, and when blood is not moving, it has a greater likelihood of clot formation, which of course inside of a blood vessel is known as a thrombus. And if that starts moving, then it's called an embolus. So there are times when people have been sitting on a flight to New Zealand or something like that, and they haven't been moving their legs around enough. And then all of a sudden the flight's over, the airplane, comes up to the terminal gate, and then a person will stand up, and then all of a sudden their blood starts moving back from their veins, but there's a thrombus in there, and then it embolizes and moves, and then all of a sudden a person's got a stroke after they arrive um, at their destination on some long airplane flight. So this is why on long airplane flights, if any of you have ever been on one, they recommend that you get up and move around and squeeze muscles in your legs and do ankle rotation and that kind of stuff. You never want to just sit and not move for a long time, especially with in the sitting position with your knees flexed, because that can cause blood to pool in your veins, and then you can develop these clots, which are not a good thing. All right, these next two slides, I'm going to suggest that you just review these slides. Go to the class webpage, go on present mode, and then go to this slide and then turn your laptop sideways, so, or your Chromebook sideways, so that you can just start getting an idea of which blood vessels are where. All right. And what you'll notice is a lot of the blood vessels are named for bones. Like subclavian here means under the clavicle, right? Axillary, well, that's your axis of your arm rotation. That's your armpit. Um, excuse me. Brachial, that's of course meaning arm. There's ulnar. There's radial artery, right? So if you know your bones, in many cases you can know the names of the blood vessels, like where those blood vessels would be relative to those bones. Okay, so this is one of the reasons that learning bones comes pretty early in the anatomy curriculum, because all of that terminology is critical for understanding locations of things like blood vessels. The next slide, of course, if we page through, this is showing veins, and many of the veins have very similar, if not exactly the same names. Okay, all right, that's it for this lesson, folks. Hope that helps. Um, Hope everybody's staying safe and still continuing with their learning. Hopefully, we'll see each other again soon.